Okay, I think we are good to start it. Hello, guys. Thank you for attending this session, especially at this time. Um, my name is Samir Malik. I'm a principal database specialist SA. Been with AWS for a little over 7 years, and I've been working on databases for over 22 years. Have worked on different major public cloud vendors such as Oracle, Google, and AWS. And I have been spending a lot of time helping customer migrate from commercial database such as Oracle to Postgres. This session is about overcoming some of those migration challenges. Okay. So this session is about overcoming some of the migration challenges from Oracle database, and I've been joined by my joined to present this session. Baji, you want to introduce yourself?
Hey, hello everyone. Baji Sheikh, and I am working as a senior consultant in AWS Professional Services. It's been 6.5 years with AWS Professional Services. I help customers to migrate from Oracle SQL Server databases to Postgres database. I have over a decade of experience with Postgres, and I have authored multiple books, and I spoke at multiple conferences. So that's about me.
Thank you, Baji. Let's quickly look at the agenda, right? So the majority of time in the session we're going to spend on looking at some of the common migration challenges and how we can kind of work around or provide resolution. But before we get there, we want to talk about why customers are migrating from Oracle database, and then we want to take a look at see why Postgres is the preferred choice of target database when they migrate. Then we're gonna take a quick peek at the database migration cycle from Oracle to Postgres, and then as I mentioned, we're gonna spend most of the time talking about some of the common and top migration challenges and how we can resolve them. With that, let's get started. This is just a quick recap. Oracle database has been around for more than 30 years, and they pioneered relational database for so many decades, and that's a wonderful database, but it comes at a premium price. So this is just a slide quickly talked about the cost associated with running Oracle database, right? So you will have Oracle Enterprise Edition, you will have multi-tenancy enabled option, then you will want to run Oracle RAC for high availability, you will have DataGuard for disaster recovery, and then overall there are some other packs, right? So it comes with a lot of bells and whistles, and it is separately priced. So if you have diagnostic and tuning pack, you will have partitioning. Overall, on one processor core license, you will spend about $123K per processor license, and then on top of that, you will have to pay 22% support cost on the list price. So if you look at the slide, one processor cost license costs over 150K just to run Oracle database on one processor core license. And then apart from that, Oracle has very punitive licenses, and then they also often do auditing, audit customers to comply with the licensing policy, so they are not very customer friendly, and those are some of the reasons why customers are looking to migrate off of Oracle. And then now we're going to talk about why customers are preferring Postgres database as their preferred database choice for migrating Oracle workloads. And one of the reason is the popularity of the Postgres open source database. This is a graph from the DB Engine page. As you can see, the orange worm for Postgres has been gradually going up and up, beginning 2013 and 14, where the major cloud vendors started providing Postgres as a database as a service or DBaaS platform on all those major cloud vendors. So it is steadily growing and catching up with the commercial database such as Oracle SQL Server and MySQL as well. Some other reasons why customers are choosing Postgres database. Obviously, the Postgres database is it's literally free. There is no cost. There is no cost to run Postgres database anywhere, and it is basically it is truly an open source database. There are some open source database such as MySQL, which is not truly open source database. It also provides an enterprise edition on MySQL, which is owned by Oracle Corporation, right? So it is not truly open source, but Postgres is true open source, 100% supported by the Postgres community. It isn't owned by any other big companies. And then, as I mentioned, one of the reasons Postgres is gaining popularity is because all the major cloud vendors, and we will look into the next slide to see what are the offerings available for running Postgres on all the major public cloud vendors. So in fact, all the major cloud vendors, they have Postgres offered as a database, as a database platform as a service on all those major cloud vendors. Postgres has a support for pretty much all use cases. So you can run OLTP workload, you can run analytics workload, you can run HTAP like hybrid workload. It can support if you need NoSQL sort of workload, you can use JSON. You can use PostGIS for the spatial queries, and it also supports several programming language and protocols. So it is very and it also has support for extensions. So it has a great extensibility where you can plug in different extension and can get support for different features and functionality. The other reason is Postgres is very similar in terms of semantics and syntax from Oracle. So if you compare the Oracle PL/SQL with Postgres PL/PG/SQL, they are very syntactically similar. So it's very easy to rewrite the queries written in PL/SQL to Postgres PL/PG/SQL. And with the advent of Gen AI, you can also Postgres also have an extension called pgvector, which can act as a data store to implement your retrieval augmented generation RAG use cases. We will dive deep a little bit into those. So it does provide extremely good vector data store for RAG use cases. And this is the slide which talks about the offering provided by different major cloud vendors, and some. If you move from left to right, you can obviously AWS has Aurora Postgres, RDS Postgres, and then actually the Aurora Limitless, we launched this week. Yeah, I think this week. Yeah, last week. It's been GA as well, so we had to update that slide. Google has Cloud SQL for Postgres, which is a managed service to run open source Postgres, and they have a AliDB for Postgres, which is basically they have built decoupled the compute and storage, and they also added a columnar engine to run Postgres on Google Cloud. They also have a distributed Postgres on Google Cloud. It's called Google Cloud Spanner, which has a distributed, it's a globally distributed database which can run active into multiple regions. Azure similarly have Azure database for Postgres, which is managed Postgres for managed Postgres running in Azure Cloud. They also have a distributed sort of database they called Azure Cosmos DB for Postgres. It is enabled by Citus extension. Microsoft bought Citus, and they implemented Citus for sharding management using Citus extension. OCI, the Oracle Cloud, also have a managed service for running Postgres. And then on the very far right, you can see other, those are not specifically specific tied to any cloud, but they can run on any cloud vendor, right? So Yugabyte is a globally distributed database, which is sort of, inspired by Aurora Postgres and also the Google Cloud Spanner. So they have taken best of both and come up with the Yugabyte solution. CockroachDB is also, it can run on any cloud. It is also a managed sharding for Postgres, and you can horizontally scale Postgres beyond one active writer node. Similar situation with the Crunchy database as well. And just a little bit on the pgvector, right? So with the support of pgvector, what it does, it support ability to store the vector embeddings, because in order to run a semantic search, you need to store those vector embedding in the database. So with the PG vector, you get the support to store the vector embeddings, and Postgres PG vector introduce a vector data type. It also supports different indexing technique, IVF, flat, and HNSW. These are the very common, two common indexing strategy you can implement. And you can do different sort of search, semantic search. Either you can use the exact neighbor search or the KNN algorithm, or you can use approximate neighbor search, right? So which is ANN, and it also provides you ability to store your vector embeddings with your operational database. So basically, you could have an OLTP database where you were storing all your operational data. You can also store along with them the vector embedding. So you can have just one database to act as an operational database and also a vector data store. And you can use different distance operator, Euclidean and cosine distance. Those are the common distance operator. You can do search based on using those operators. And then once you use PG vector for vector data store, you should be able to satisfy those retrieval augmented generation use cases. So you can do a semantic search. As I mentioned, semantic search is not a textual search. It knows the context of the search, right? So for example, if I say, give me if I say just the word bill, right, BILL, it could be a name, it could be a check for or it could be bill of rights, anything. So it knows the semantic meaning of the search. So you can do semantic search using that. It can act as a recommendation engine. You can build a chatbot or something which could do recommendation based on your personalized search. You can do sentimental analysis, right? So based on the feedback or survey you do, you can detect the emotional and sentimental analysis. You can also build chatbots to enhance the experience with the customer's support. This is kind of a methodology, right? So we have worked with customers. They have hundreds and thousands of databases running, and they don't know where to start, right? When they think about migrating from Oracle to Postgres, they have thousands of databases. They don't know which one to pick, right, for a pilot or where to start, right? So there are kind of two different categories they can start with. One is the simple one, and then one is the complex. Obviously, the complex workload will have a lot more migration effort than the simple one. So as you can see, the migration effort start from green, moving towards complex. It become more and more. The simple would be mostly it is very few schemas. There are most importantly your application logic is not stored inside the database, right? So because back in the days when Oracle introduced the PL/SQL, a lot of customer especially for custom application, they wrote most of the business logic inside the database using store procedure function and packages. If your workload is business logic is outside the database, then it's pretty easy to move the application to different database. On the right hand side, it's complex. You will have multiple schemas and thousands of objects. You may have embedded SQL, which requires a lot of refactoring, and similarly, most importantly, your business logic is hard coded inside the database. So you have to rewrite all of those into Postgres compatible PL/PG SQL. So you can choose. Some customer they started with simple. They want to see how fast they can do a simple migration. Some customer they want to bring the hardest workload and see if that can be migrated, right? So different approaches. Different customer take different approaches. Some customer do both at the same time, or some customer meet in the middle and say, I want to bring a medium sort of workload, which will give me best of both worlds. This is a typical database migration cycle. Obviously, you could start from schema object, for example. You can pick up all your schema objects, your table, your indexes, your views, your all those schema objects, right, which are stored or created as a database object. So you start with them and you start converting those to the target Postgres database. Then you can also look at application data. You can go either way. but you have to go through the cycle in fullness. So you can start converting your application code, whatever application code required to change, you have to change that. Then you have to do data migration at some point of time to basically check your application functionality, whether it is functionally performing the same as it was performing with Oracle. So how did my slide move? And then basically you have to do it multiple iterative times to see you get comfortable with the process. Two, you are functionally able to verify your application is functionally performing the way it should be. And then finally, when you are satisfied, then you will do a cutover, right? So there are different approaches to do cutover. Some customer, they just do, they stop their source and then take some downtime and then do the cutover and make it the new primary. Or some customer, where there is a critical application, they want to have a fail-safe mechanism to make sure that if things go wrong, I can fall back on the previous one. So they do sort of replication setup between those two and make sure that whatever, even after doing initial cutover, they can fall back in case things go south. So different strategy used by different customer for the cutover. But I think before getting to the cutover, this life cycle is very important. You want to do multiple iteration to make sure your compatibility, your performance, and then once you have done this, then you can move on to the cutover section. And I think this is a good segue for me to hand it over to Raji, and he's going to talk about the top migration challenges.
Sure. Thank you, Samir. So we have come up with specific challenges. The reason behind come up with these challenges is if you don't do this analysis at the initial stages of the migration, you will face issues at the functional testing and performance testing, and you have to come back and do this analysis, which will ultimately change your migration timelines, right? So it's really important to assess your schema objects, code-related objects before you start with the database migration. The first challenge that we are going to talk about is number versus numeric, number data type in Oracle and numeric in Postgres. So in number data type in Oracle can hold 38 digits, really long number, right? So in Postgres, equivalent is numeric, which can hold 131,000 before decimal and 16,000 plus after decimal. So this is the reason many DBAs think that the direct conversion of a number data type is numeric, right? So that's the reason you see all number data types are converted to numeric at the initial stages. But Postgres has other number-related data types like small int, integer, and big ints, which holds 2, 4, and 8 bytes of data. So if you look at the numeric, specifically numeric data type in Postgres, so the size of the same number with a numeric data type is 12 bytes, and with integer data type is 4 bytes. So there is a difference in storage as well if you choose the numeric data type. So hence the performance penalty as well at the end of the day. So that's the reason it's not numeric is a not direct conversion of a number data type. And also if you look at the performance, so this query is between two tables with numeric columns, and the second query is integer columns. You can see the performance difference. There is almost 20% performance difference between these queries. And how do you do that conversion? So if you only want to look at the metadata of the Oracle number data type and want to convert it into Postgres, so this is the best way. So if there is no scale for number data type, for example, number 4, 0 or 10, 0, 12, 0, there is no scale at all. So there is no point of having a decimal related data type in Postgres. So if there is no scale, either you can go to int or big int in Postgres. But based on the precision, if your precision is less than or equal to 9, you can go to integer. Otherwise, if it's greater than 9, till 18 digits, you can go to big int. You don't need to consider numeric data type or any decimal point related data types. But if you have a scale and your application is intended to store those decimal point numbers, then if a scale and precision both is 15 less than or equal to 15 digits, you can go for double precision. If it's greater than 15 digits, then that's where the numeric comes. So this is only based on metadata, but there is more to it. If you want to do a deeper analysis, you can look at the actual data of the Oracle. If there is a number data type 10, 2, but you're not really storing the decimal points inside the table data, then you don't need to have any numeric related data type. So yeah, that's going to take time, but if you want to do deeper analysis, you can look at the data and come up with that analysis.
Just to quickly to add, I think this number versus numeric is very intuitive. So people, when they start converting, they will immediately look at a number, say, oh, I'm going to use numeric. And in fact, some of the tools like, the schema conversion tool, from AWS, it used to use the same default. As soon as you see number, it will use numeric on the target. So that's something, we need to deeper look into it. And then, as he said, if you want to actually look at data, but not by the definition, like column definition, you can use, like, for example, dbms_length package and get the length, what is the max length you are storing, and the range. And from there, you can actually pick up the right data type based on that. So it's up to you. But it's very important, both from the storage perspective, you will pay more for storage, and there will be performance penalty as well.
True. And the reason behind those tools to choose the direct numeric data type is if the number data type is 4, 0, as per this analysis, you can go for small int. But if you don't discuss this with the application team that this data type really needs, it will go beyond the 4, 0 or small int or not, you need to discuss that with the application team. And then, if it's intent to go beyond that, you select the, int is a data type instead of small int. Because if you select a data type in Postgres, changing that data type will take, again, a long process. And the second challenge is null versus empty strings. In Oracle, null and empty strings are equal because internally Oracle converts empty strings to null values. But when it comes to Postgres, empty string and null are different values. If you insert null and empty string, and you have to query as per what you inserted, not with the just null. So here is an example. In Oracle, you inserted null and empty string, and when you query for null values, it returns both the IDs with null and empty strings. But in Postgres, if you insert null and empty string, and if you query for null value, it gives you only one record, which is null, and then empty strings, the record with empty string. So we have seen a lot of issues with this. This is not just for the queries. There is more to it. If you have code objects, lot of code objects, thousands of procedures, then that's where the issue comes. So if your business logic has conditions like column is null or comparing two text columns, column are not equal to column 2, these kind of conditions are there, then you need to change those conditions, because if it's not a null value, then the first condition will fail, right? So here is a simple table to understand it. So if it's empty string is null, Oracle says it's true, but Postgres says false. So empty string is not null, then Oracle says it's false because empty string and null are equal. And there are NVL function in Oracle, and collage functions, decode functions. All this is a simple table to represent all that. But what is the solution for that? So here are some recommendations. Instead of simply querying text column is null, you can use null if function, which converts the empty strings to null, so that you'll see the same results as Oracle. But adding this null if there are only few queries or few code objects, you can go and change it. But if you have thousands of objects and every function procedure has thousands of lines, you cannot go through every object and change, look for that condition to change to null if, add null if. But there are two ways. One is if you have less number of objects and less number of lines of code, then you can go ahead and change manually. But other way is to change the application. So if application is sending empty string value, change it to null. So you can make a change at application instead of changing thousands of procedures. So whichever is easy for your migration, you can go ahead with that. So we talked about null and empty string. Now let's talk about only null values. So in Oracle, one null value equals to other null value. But in Postgres, null value is an unknown value. So one unknown value is not equal to another unknown value. So two nulls are not equal in Postgres. So what happens now is if you have a unique index, composite unique index, so if you're inserting null values in one column and unique values in other column, as two nulls are equal in Oracle, so that unique constraint will throw you error for duplicate values. But in Postgres, null values are not equal, so you can insert as many as you can. So if your application is to behave like as Oracle is function, then you'll see functional testing errors, right? So the one recommendation is to go with the partial index, where you create a unique index on one column with a where clause of name is null. So this will avoid inserting duplicate null values. And other option is Postgres 15 has nulls not distinct clause. So if you create unique index with that clause, so it treats all nulls as same. So it behaves like Oracle. So that's one is null versus empty string, and you have null versus null as well. And this expression equal to null. So if your application has name equals to null as a predicate, then it works in Oracle, but in Postgres, this null is literally takes as a value. So null value cannot be queried with this unless you set this parameter. Then you can see that value. So now name equal to null returns 0 records, but after setting this, you can see that record. With this?
No,
I don't think.
Just instructing Postgres to treat convert this expression to equal to null, right? So it basically transform null equal. So it basically make the expression the same. Name equal to null, it will start transforming null equal to. So you can compare. We should set this parameter. You can compare the value with the null, and it can tell you whether the value is null or not. So that's what it does. It's doing. Yeah, it doesn't create any index. No, there is no. I mean, there is not a function. I think implicitly, Postgres will convert this expression. It will rewrite the SQL and just convert those to.
Those are actually immutable functions, so I don't think that. Yeah, it will use the index. Yes. A date and timestamp related data types and functions. So Oracle has a data type which comes with date and timestamp. But if you choose a date data type in Postgres, it's not equivalent to date data type in Oracle, because Postgres date comes with only date, not timestamp. So you'll have to go with timestamp with time zone or timestamp without time zone based on your application. Your application is supposed to insert from single time zone, you can have without time zone, but your application is from multiple locations, then it's good to have with time zone data type. And SYSDATE, we have seen lot of tables comes with default date as default data time as SYSDATE. So, but there is a confusion which data type, which function should be used in Postgres, which is equivalent to sys data type function. So here is a simple test. So we use all date timestamp related functions within a single transaction. So, and in Oracle, SysDate within a single transaction, it takes different values. You can see the results. So there is a difference between two timestamps, but it's a single transaction. So within single transaction in Postgres, we have used all date and timestamp related functions, and you can see only one function that returns the same different timestamps in single function, which is clock timestamp. So nearest closest date and timestamp function in Postgres, which is related to SysDate, is clock timestamp.
It's like the repeatable read consistency, right? So only the clock timestamp will give you the actual read committed data, right? What exactly time at the time, right? Which is it slept for 15 seconds, so it will give you time after 50 seconds. Rest of them, they are repeatable read. They will give you the same timestamp no matter how many times you call. So it's the same transaction. So it's very important you invoke the appropriate function to do it. If you have to call that function multiple times within a transaction.
Right. And toDate function, we have seen a lot of places, lot of code objects use this toDate function in Oracle with only single argument in with this. So toDate of SysDate returns the date in Oracle, but in Postgres, toDate needs a couple of arguments. You need to specify the format as well. So that's how it works. So wherever you see toDate function, you need to convert into two arguments. And difference between dates, in Oracle, difference between dates is a number. But in Postgres, a difference between two dates is number, integer, but if one of them is a timestamp related column, it returns interval data type. So you have a date column and you have a timestamp with time zone or without time zone columns, and you are comparing those two to have a number condition, then it will fail in your business logic because it's an interval, it's not integer. So you need to keep a note of it. This is with Aura FCE extension. So this extension gives you the same behavior with date timestamps as in Oracle. You can see the difference without that extension. You can see SysDate returns the timestamp as well. A date column returns the timestamp as well. But without that extension, you don't see that timestamp. It's only date. So either you can use that extension or you can make those changes in application code. More functions, trunk functions and date trunk functions. These are available in Postgres, but it's just that parameters are different. So you need to see where these functions are used and change those parameters. For example, date trunk, the parameters are reverse in Postgres. First you use the day and the time date, but in Postgres, it's reverse. So whenever you see these functions, toDate functions, trunk, date trunk in your code, you will have to assess the entire function. Synonyms, the advantage of synonyms is you don't need to have a schema qualified name. You don't need to specify owner or object name, so you can mask that entire schema qualified name. That's one of the advantages. So you don't need to hard code anything. But there is nothing directly related to synonyms in Postgres. But you can use search path if you have a different schema, table in a different schema, like private schema. Then you cannot directly query with the table name. But if you want to mask that schema name, then you can have that schema name inside the search path, and now you can query the table without that schema name. So that's this is one kind to avoid that qualified name.
Yeah, and a couple of comments on synonym, right? One of the important use case of synonym on Oracle is to hide the name of the object, right? For example, you have a sensitive table, let's say employee table, right? And I want to give you a read-only access on some column, right? And only some rows, right? So you can implement row-level security, and I don't have to tell you the name, right? So you can create a synonym, and I can give, instead of employee table, I can say some random name, right? So when I give you the access, you're going to be querying some random name, not the employee table, right? So that's a way to mask, letting people know what you are actually querying upon, right? So that's something is very frequently done in Oracle database. So there is no equivalent functionality in Postgres. And in Postgres, the default search path is the user which is logged in. And in this case, it's test user and the public schema. So if you don't modify your search path, it's gonna look into your schema and the public schema and see if it can find that object. It couldn't find because it was set to default. When you modify it and add that private schema in the search path, then it goes under those three. It will start from left to right, and whichever first it will find, it will show here. So that's the case here.
Yep. The next one is query hints. We see a lot of application queries with the hints in Oracle, but there is no direct hints in Postgres core. So if you directly convert that, if you directly execute that query in Postgres, it just ignore that entire query hint. It takes it as a comment. But we have an extension called PG hint plan. If you create this extension, still the syntax is not same. Like in Oracle, you still need to make the changes to your queries, but at least you can use the query hints as you want. So PG hint plan is the extension. So this is an example. This is a query which is taking nested loop in your plan, but you want to change that. You can just have a hash join in the query hints, and it will take the hash join. So this is one way of using, but still you need to change all your queries which are using hints in Oracle because syntax is different. Autonomous transaction. Autonomous transaction is nothing but transaction inside a transaction, but irrespective of the parent transaction, child transaction can be committed, and parent transaction can be rolled back. But in Postgres, if you begin a transaction, irrespective of how many child transaction inside it, if parent transaction is rolled back, everything will be rolled back. So there is no autonomous transaction kind of thing in Postgres. But this can be achieved in with dblink extension. So dblink extension, if you use dblink extension query inside a transaction, it actually queries the database in a different connection. So irrespective of this parent transaction is committed or rolled back, that will be executed and committed in a separate connection. So this, at least this is a workaround for autonomous transaction, but the issue is if you use more dblink connection queries, then you will end up with losing your connections. So you will at some point you will see max connections reached as well. Sequence caching. So in Oracle, if you have a cache of 10 for a sequence, and if you execute that next value in different sessions, you will see a sequence of values. But if you have that cache of 10 in Postgres, and if you use different sessions, next val, you can see that cache will be added to the sessions. So in the same session, 100 and other session 110. So if a application connections are coming and one query executed next val and other session executed, then that's not a sequence. So you can see basically gaps in your sequence. One way to avoid this is to come up with your own workaround, create a sequence table and use next val functions to update that sequence. But the issue is you cannot have parallel sessions because this is an update to the same table.
And the reason for the sequence caching issue is because in Oracle, the sequence is cached at the system level. And in Postgres, it's cached at a session level. So, and the problem with that is, you can see inconsistency, and the session A will have value 100, then B would have 110, and the session A again could get a 102. So you're breaking the sequence, and it can break your application logic. So it's very important. This function is a workaround, but it's not very performant because you are basically updating the table every time you do an increment, but it's a workaround. So typically, it is useful if you don't have to maintain the order of the sequence. If you don't care about the order, then I think it should be okay. But if you do care about the order, then you have to go through this workaround.
This will contribute to transactions counter as well. So you'll have more transactions. Hierarchical queries. So one parent can have multiple child, but one child can have one parent, right? So best way is employee manager hierarchy, you can see. So these hierarchical queries, it's simple in Oracle because there is a direct syntax connect by and start with. So if you have an application which has this kind of hierarchical queries, you'll see a lot of these syntaxes, but these are not directly supported in Postgres. So Postgres, you can work around it, but it's a complete rewrite of the query. So you don't see connect by start with, it's a complete rewrite with a CTE query with queries, with recursive queries. So you'll see the same output, but it's entire different query. Here are some bonus tips. Global temporary tables. Postgres temporary tables are session specific. If you create a temporary table in one session, the other session cannot see. But in Oracle, there are global temporary table option where one session can create a temporary table. Other sessions at least can see it, can try inserting the data. The other sessions don't need to create that temporary table. But Postgres, this can be achievable using PG TT extension. So you can install this extension, and then if you can create a temporary table which is global for all the sessions. Bulk collect. So bulk collect is, you see a lot of this bulk collect syntaxes in code-related objects where you are inserting the data. So inserting one by one record instead, you can go for hundreds of thousands of bulk records, which will improve the performance. So in Postgres, you have array aggregate function, which you can use to have the same functionality as bulk collect. External tables, using Oracle table. In Oracle, you can directly create external table using the file system related files. But that's not directly available in Postgres. You can use either copy command to std in or out the data, or you can use file ftw extension through which you can create a file system level file, and you can create a table using that file. So it's achievable using file ftw extension. That's all.
Is there any question? I know it's very late in the day. If you still have some energy to ask any question, feel free. If not, we want to thank you for your time. I hope this is useful. Do let us know if you have any question, any feedback. Thanks again.
Sure. Thank you very much.